Hi everyone, this is Ashwin here. In this video, we are going to explore RAG tutorial with custom knowledge. So while using LLMs, we always use the knowledge which is already there in the LLM. If we want to use our own files and ask questions from the files and get an answer in a more natural way, we have to use this RAG. The full form of RAG is Retrieval Augmented Generation. So in this tutorial, we are going to use a PDF and ask questions from the PDF file. And you don't have to limit only to those PDF files. You can have multiple documents and along with different types of text data in a single folder. And we can process everything and use OpenAI or open source model to answer your questions with the custom knowledge base we have. Okay, let's do the setup. First, we have to install modules. So install modules. First, you have to open CMD, and you have to set a environment variable here. Set cmake orgs equals minus dggml underscore CUDA. So you have to enable this option if you are using a CUDA environment. You have to install Visual Studio build files along with the C++ files that is present, and you can set this environment, and later you can run this pip command, pip install llama cpp python. So this is the module you have to install. So this is the core module that we'll be using. You can also use LangChain, but for this tutorial I'm going to use llama cpp as it has better customization, and the results are coming very good with this module. So you have to enable this if you have NVIDIA GPU. I will also add that as a comment. Set the variable if you have NVIDIA GPU, or ignore it. Then install it, and after that you have to install all the requirements. Pip install or requirements.txt. So I already have the requirements in the text file. So these are the modules you have to install. You can also install it separately using regular pip. Instead of that, you can just install using a single command, which is easier. So after installing all the modules, we can import it. Import modules. Now we have to import multiple modules for this. Let's import the basic ones. Import OS, import warnings, dot filter warnings. I'll ignore it. And then we will import all the Llama Index modules from Llama Index dot LLMs. I think because of the zoom, it's just using the scroll bar. I think we could do the zoom out, and now it's giving the response correctly. Llama cpp, import llama cpp. So this is for importing open source model. You can also use OpenAI. So for that, you can use llama index dot LLMs dot OpenAI, import OpenAI. You can just specify the model name in the OpenAI and you specify other arguments and use it directly. Both are replaceable. You can use anything you want. And then from llama index dot llms dot llama cpp dot llama utils. Okay, it just given me everything. I just need the llama utils and import messages to prompt, completion to prompt. So in this tutorial we are going to use a single question and response. If you want to integrate chat responses, that you can also do, but I'm going to stick with a single question and response for this tutorial. So for additional documentation, you can refer Llama Index and change few parameters in order to incorporate the chat module. And then from Llama Index dot core dot node parser import sentence window node parser. So this is for processing the extracted sentences from the PDF or Word document. And from Llama Index dot core import. Now we will import multiple modules. Vector store index. We'll just comment this, and service context. I think other than that we need a simple directory reader. So this will load all the documents, any type of documents in a single shot, instead of us processing each file in a different manner. And then document. So all the documents will be passed into a single document file, which we can use it for further processing. And then from Llama Index dot core dot post processor import metadata replacement post processor and sentence transformer re-rank. I think that's pretty much it. If we need additional imports, we can do it later. I think we can also import regex for doing some pre-processing. Let's run this. And then let's initialize the models. Initialize models. So first one, I'm going to import an open source model. I already downloaded Mistral 7 billion model in a quantized version. It's around like 4 gigs. You can download it from any URL. I'll just specify the model URL here for reusability. So this is the model URL. You can either download it or you can just use the model URL directly to import it. So LLM equals llama cpp of model path. As I said, I already have the Mistral model. Sometimes if you are using different models, means you have to specify some prompt template, as each model has different prompt templates and different way of training they have done. You have to specify the prompt template. But most of the time you can just directly import the model and use the inbuilt prompt template that they already have. So here I'll just set the temperature as 0.1 to avoid unnecessary hallucination or more creativity, as we just need to extract the facts and see it as it is. Max new tokens, I will limit it to 256. Sometimes it might extract data, like very big data, and explain it in a very detailed way. It depends on your use case, but for now I'll just limit it to 256 tokens. Context window, this supports around 4K tokens. To have some buffer size, I'll just stick to 3.9K tokens. Then model kargs, keyword arguments, and here we can specify how many layers we want to transfer to the GPU. So if you don't specify this argument, means you will only use the CPU, which will be somewhat slower. I have a 1050 Ti, which is lower end graphic card. At least you can transfer around like 20 layers and process it and do the rest of the processing in your CPU. So you can specify the number of layers. I think total they have around 33 layers. So you can transfer based on your GPU size, you can increase the number of layers. And then we have messages to prompt. We already imported that module so that they have a specific message for RAG and completion format. You also have that. Then verbose equals true. So this will just indicate how much time it is taken for processing and how much memory it is using. If you want to disable it, you can disable it by setting it to false. Let's run this. Now you can see, so this is the GPU. So found one CUDA devices. This is the graphic card, and this is the CPU buffer size and CUDA buffer size. I just offloaded around 2.5 gigs to the GPU, and these are some additional details. And if the installation is successful, the BLAS will be enabled to set it to 1, or else it will just only use the CPU. If you don't want any of these messages, means you can just set it to false. And you can see available chat formats from metadata, and it just guess the chat format. It is Mistral instruct. And if some models are coming new, means you have to update the modules, especially the Llama Index. And based on the model, it will automatically guess the chat format using this modules we already imported. Or you can also specify it manually if needed. So here you can see some instruction and how the formatting is being done. So if you don't want this information, set it to false and it will be very clear. Now if you just want to check whether it is working or not, have llm dot complete, and you can just ask a question. What is AI? I think it will give you a response, and from the response you just print the text. Response dot text. Run this. So currently the streaming response is not enabled, but for RAG we will enable streaming response, and this will be much faster. So here you can see how it replied. So it just explains about like artificial intelligence, and like that you can ask any questions you want with the LLM, similar to how you use ChatGPT. So this will let us know that this is working, and this is for open source LLM. To use open source LLM, and I'll just comment this, and I will have to use OpenAI model. Again, I will have LLM and OpenAI class initialized, and here you just specify the model name. I'll just use GPT 3.5 Turbo. Okay, and API key. I have the key in my environment. If you have the key, you can specify it directly here. Get environment variable, which is OpenAI API key, and here also you can specify temperature equals 0.1, and max new tokens equals 256, and here messages to prompt we will just use the same. and completion to prompt, use the same. And here also you can set verbose equals true or false. And by default, OpenAI uses 0.7 or 0.8 temperature to have like better results. It will be a balanced temperature. So I will just use that temperature. Here also, if you use that, it won't change the result that much drastically. But for OpenAI models, it will affect the results. So based on your use case, use the temperature or change it accordingly. Let's run this and run this one. Now this is like much faster and the response will be slightly vary, depends on like which model you are using. If you don't have a good hardware in your local machine, I would suggest to use OpenAI, as most of the heavy lifting will be done on the API side. So it will be very easy to run it in your local machine. Okay, now that we have initialized the LLM, let's load the documents. Load the documents. So I will initialize a variable documents equals simple directory reader. Inside it, I will specify the input directory. You can also specify the exact files that you want to import. So this is the directory I am going to use. Dot load data. Let's run this and len of documents. So it has like 10 documents. We will also see what is the document that we are using. So this is the document that we are using. This is a research paper, and I'm just using it for this demo tutorial, and it has like 10 pages. So each page will be converted to a document, and we will ask a specific question from this document and see how the AI responses. This document is very big. You cannot pass the entire thing to the model and expect to get better results. That's why we are using this retrieval augmented generation pipeline to answer it effectively corresponding to the question given. Okay, so you can explore the documents, like what is inside it. Let's explore like documents of one, like the first page dot, and these are the operations that you can do. There are many functions here. Let's say metadata. So this is the metadata. It will give you the file path, page name, and what is the type of file and when it is created. Every metadata information it will be displayed here. Let's also explore other things like doc.text. So this is the whole page that is present in the document. You can do some pre-processing and process like remove unnecessary text from this to make it more clean, but we are not like doing any classification to remove special symbols or numbers from this text, as each number or special symbols can be used in the response based on the question. So you can do some basic pre-processing for this. Again, it depends on the documents we are using. If there is unnecessary text like this Journal of Advanced Zoology available online, so these texts, if you want to remove, you can definitely remove it. So I'll just comment it, or instead of commenting it, I'll just display a small chunk of the text. So this will be or I'll just display the whole. I think it's fine. And then we have to clean the text. So I'll create a function def clean text of how to pass the text, and then we will replace additional spaces. So all we do is if there is like 2 or more spaces, we will just make it as a single space to save some characters. So text equals re.sub of r space plus comma, and this will be replaced with the single space and text, and then text equals text dot strip. It will just remove any leading or trailing white spaces, and we will return the text. Return text. Now we can iterate through these documents and just clean this text, as it's like a dictionary. If you want to explore the full documents of 0, here you can see it has all the key and value pairs. So this is the whole document, and maybe I'll just display it at the top, and let's iterate it. For doc in documents doc text equals clean text, just pass the same variable, clean the text data. Again, this is a basic cleaning. If you want, you can do further processing according to your data that you are having. Then we will build the vector index, def get build index. We have to index all these text into vector database. So we will split each sentence and store it in a vector database. So if you give a question, it will extract the embedding and use similarity metrics to take top 5 to 6 sentences and generate answer from those sentences alone. So let's build this index. So we will pass the documents LLM embedding model. I'll just pass it as embed model. So local. So these models can be downloaded from Hugging Face, or if you just pass the model name, it will directly download it. As it's a small model, you can just directly download it and keep it in the cache v1.5. So this is the smallest and best embedding model that I'm going to use. And again, you can change the model if you want. And then sentence window size. Sentence window size equals 3. Let's say if you are taking a single text, let's consider this text. If you are taking a single sentence, sometimes the related sentence or the neighboring sentence will also have some good meaning out of it. So we will take this nearby sentence like before and after as well. That's why we are specifying the window size as 3 here. And you can also increase the window size accordingly. And then create node parser to process the documents. So here we are creating the node parser, sentence window node parser, which we imported earlier. Specify the window size, which is sentence window size, and window metadata key. So after processing, if you want to extract the key, that is what are the contents that is present in the sentence window, you can use this key. And original text metadata key, I'll just keep it as original text. So these keys you can retrieve it later. You can also keep it as window text and original text. So original text is the text that we will retrieve, and window text is just the neighboring sentences of the original text. So this will process all the documents that we had above, and then We will initialize service context with LLM, embedding model, and parser, node parser. I think I missed an R here. And here service context equals service context of, pass the LLM, and then embed model, then the node parser. And there are different types of node parser that is present. You can always explore the documentation if you want to process the documents in a different way or in your custom way. Everything is customizable, but for easier use, I'm going to use these specific functions. So we have combined everything into this service context. Then we have to create the index. So index equals create the vector index, vector store index dot from documents of, pass the documents and the service context. The service context will use the embedding model to generate embeddings and store it in this vector database. So this will be used for retrieving the relevant sentences for the question that we ask. And then we will return the index. Okay, so this is one function. Let's create another function, def get query engine. So this query engine will be used to ask queries from the documents we have. So query engine, we will pass the vector index that we have, vector index, comma, similarity top k equals 5. So I'm just taking top 5 relevant documents from the corpus that we have, and re-rank top n. So after taking that relevant documents, I will just do another re-ranking mechanism to sort the documents which is more relevant to the query. So I will just take only 2 to reduce the context that we have. Again, this is customizable. Here we will use the post processor equals metadata replacement post processor of, target metadata key will be window text, and then we will have a re-rank. Re-rank equals sentence transformer re-rank of top n equals re-rank top n, which we passed in the function. Then the model, again if you have a specific model, you can pass it. Maybe I'll just pass it here, re-rank model equals BEAI / BGE re-ranker base. Again, this is also like similar to the above, but this is for doing a re-ranking, and pass the re-rank model here. And then we will build the query engine. Build query engine, post processing for the context retriever. and query engine equals vector index dot as query engine. It's not suggesting anything, so I'll just go for it as query engine. And as I said, there will be multiple engines for this vector index that you can explore, like the chat engine and synthesizer, etc. And here similarity top k equals similarity top k, and node, okay, again it's not suggesting, node post processors equals post processor comma re-ranker. Maybe re-ranker would be good. Re-ranker, and here you can specify whether you want streaming or not. Maybe I'll just have it in the new line. Streaming equals true, so that you can get a real-time response from the LLM, and it will be more realistic, and you won't feel that it is taking long time. And then return query engine. Okay, let's see whether it works. Let's initialize the vector index. Get build index of documents, and I think it's better to have the full arguments. Get build index, LLM will be LLM, embed model, we already passed the embed model, so we don't have to pass it here again. And sentence window size, we'll specify it as 3. I think that is it. Let's run this. Okay, so here I think we have to use service context from defaults. Just run this again. Okay, I think it is processing our documents which have like 10 pages, and you can also store the vector index in your local directory. So store the vector index. So you will say vector index dot storage context dot persist. You just have to pass the persist directory. I will say vector storage. So this is how you can store it. Let's see. So here you can see the vectors has been stored here, and if you want to load the vectors again, load the vector index, that would be vector index. I think we have to import another function, load index from storage. I think this will come under this core. Okay, let's load it. Load index from storage. You have to pass the directory, storage context. That is also we have to import. Storage context. Okay, now storage context dot from defaults persist directory. Pass the directory that you have used. That will be vector storage, and you have to pass the service context like this. The service context is needed, so you have to like initialize this outside, or get both node parser and service context from the function, and pass it here. So here service context equals service context. I won't run it. I'll just comment this. If you are using it means you can use it directly. Now that the vector index is ready, let's build the query engine. Build the query engine and get vector index, query engine equals get query engine of, you have to pass the vector index which we already created. Re-ranker model I already specified, and similarity top k and re-rank I am going to use the same as it is, so I don't have to pass all these things. If you are changing these parameters, you can specify the parameters here. Let's run this. So if you are running it for the first time, it will download the additional models which you don't have. So just leave it for some time, and once the cell is run, you can proceed to the next step. Get response from LLM. Now response equals query engine dot. It has like many functions that you can use. You can just only retrieve, or you can do the query, or you can just synthesize or compress the extracted contents. Anything you can do. So I'm going to use query. I will ask about, let's see the document, and here let's ask about this KBS. Okay, explain about KBS, and you can print the response quickly, like response dot print response stream. So it will stream the response in the Jupyter notebook. Run this. Now you can see it just stream the responses. First it will take all the embeddings in the backend and it will stream the responses. If you want to know what is happening in the backend, you just have to specify verbose equals true at the top here. Now you can see the KBS is a computer system that provides advice within a specific domain by utilizing knowledge provided by the human expert, and it will use various forms of rules, frames, cases, and inference engine algorithm to reach conclusion. Let's check the reference text. Now here you can see it just slightly changed few things, but majority of the information are present in this document. From this big document we just extracted the information and got our answer. You can also ask about other things. Let's ask about this AI in e-commerce. So I will copy this and paste it again. Explain about AI in e-commerce. I'm not just typing the exact sentence, I'm just typing it in a more natural way. Let's run this. So AI in e-commerce provides a competitive advantage to the industry by offering a personalized product recommendation based on factors like size, color, brand. This enhances the shopping experience. Let's see. It's a competitive industry and is becoming demanding in core commerce business, and it will help discover products with recommended size and color and even brand. So it's not saying the exact thing as it is. It's just augmenting and providing an answer in a more human-like way, as you can see here. If you want to extract the text from this, you can use response dot get response dot response. So this will just give you the text as it is. It won't stream it, because if you want to save it in a variable means you have to use this. use this to save it in a variable. Okay, and then if you want to get the relevant context, like what are the extracted information from the text, you can also do that. Response dot source nodes. Now here you can see like multiple nodes. Actually it only have like 2 nodes in it. It has lots of information, so it has 2 nodes. So let's explore about node 1. Just specify the index, and from this it has multiple keys. I will go for the metadata. So dot metadata of, I will get the original text. Now here you can see A is helping shoppers to discover associated products with recommended size. And let's see about other node. And this is also A and e-commerce related, so it extracted the information pretty accurately. And if you want the window text for this, window text, now you can see it just got the neighboring sentence as well, before and after. So this is just for the application that we have saw. And if you go to the previous node, I think both are similar, but in I think in a different paragraphs. So to explore that, you can also ask about the page label, like which page it is coming from. Have to check the metadata for that. So page label is there. So this is on the 9th page, and the another text that is also in 9th page. Okay, so that's how you can explore the context from the response that you have generated. And this is how the RAG mechanism works. And you can get this notebook in the description. And there is also advanced RAG mechanism that you can implement. Maybe I will implement in a later video with all core components explained in detail. But this is the intermediate part where you use additional post-processing mechanism to enhance the results. So I think that's pretty much it, guys. I hope you like this video. If you have any queries, please leave a comment below. I will definitely answer those. And apart from that, if you like this video, hit the like button and don't forget to share it with your friends. And I'll see you guys in the next video.